Here. Oh, okay. Okay, good to be back. Welcome back to the stream. And again, another week with Chris Condren. Sorry we couldn't connect the day before, but better late than never. Maybe we'll leave you with some things to think about over the weekend of event sourcing and event modeling and all the things that we cover. So just before we went live, Chris, we got into a chat way ahead of ourselves and started to talk about writing your own event store. So uh, you said that you're writing your own event store in your current power models just as a in place event store to be able to move forward. And I think that's one of the benefits of event sourcing is that how amazing it is to be able to swap in technology for whenever you need. So
And so one of the things is we're using React2Domain, which is an open source .NET toolkit for event sourcing.
mhm,
Actually, we're also James Gill is leading the charge on doing
mhm,
what he calls R2D2, which is our next version of React2Domain, right?
yeah,
Um, but in there we created an interface by Stream Store,
okay,
right? And so we can just swap in any implementation of event source now and event store that we want to use. And I roughly modeled it on the event store interface. And I originally did this back almost 10 years ago, right? But I deliberately did not implement everything. So
right,
like I got rid of, like there's the resolved event and there's a bunch of weird stuff that goes on in the all stream event. And I just said, no, all events are resolved. You know, nobody needs to look at the link twos. That's a detail of implementation. Nobody really needs in any line of business app the the competing consumers. So that's not supported in it.
right.
But yeah, we also don't do
But like, where do you need it? Like, right? Like,
yeah,
up until what point do you need it?
you need it when you're building distributed
Yeah,
systems
exactly. And how
across
many
multiple
need to
sites.
be distributed?
Yeah, no. Your
The
line of business app
infatuation
doesn't need
with
it,
yeah,
you
there's
know,
an
and
infatuation
honestly,
with microservices and premature optimization to have multiple
yeah,
services so that you can be at scale because your business is going to go ballistic next week, right?
yeah. And once I started working with the dev team at Event Store,
Yeah.
I realized the number of defects and problems and overhead
Yeah.
that feature added in to what was otherwise a really straightforward and powerful product, right?
Yeah.
So just getting rid of that, not worrying about it is huge because the 1% who need the feature, they can go write it or they can go grab Event Store itself and deal with the overhead.
Yeah.
But we don't need it. Why do you need it? The other thing that was interesting was we've codified that the event type projection, the
Yep.
built-in projections of event type and event category, I actually realized they're not really projections, they're indexes.
Yeah,
Because they're
exactly.
writing physical events into the log that you can then read streams off,
There's a
right?
lot of similarities between this approach, especially when you're doing file based, with history and
Yeah,
Git. When you look at
yeah,
the index files, it's all
absolutely.
just optimizations on how to find these objects that are referenced. And you think of a large Git history, it's amazing how fast Git is at finding anything that you want, even when you're looking at incredibly large code bases. So when you look at the Linux kernel,
Yeah,
why do they use Git? Right, that's a lot of code, and you're worried about the history, right, in your little startup, and there's no way that you're in any way, that level of scale. But the I think the point that I want to try to make is how
the startup is as
similar the
much code.
indexing is with what you're doing, right? You can do
I was gonna say, okay,
symlinks, all sorts of stuff. They can do all sorts of fun stuff, right?
yeah, I was gonna say if your startup has as much code as the Linux Foundation, you're overbuilding.
No, no, I'm thinking the data is the same as the code, right?
Okay,
Like, yeah, yeah, no, yeah, I think you're overbuilding. And if you can somehow afford to build all that, maybe you should just not spend the money and retire. But
yeah,
anyway,
exactly. yeah, so, but once you make that, so one of the things I designed and I talked about, as part of the VNext for Event Store, but we never were really able to implement in my time there, was once you realize that the category really forms the equivalent of a superset of tables,
Yeah.
right? You then realize you actually have an n-dimensional hierarchy that you should be able to specify of streams, each
Yes.
one of which gets its own, as we talked about, point. But
Yeah.
those can get written to disk with the original commit. So one of the things I was a big fan of, and we've done variations with event stores that we do that. We say, okay, these are not projections. These are indexed. When we write
Yes.
the event to the stream, we're going to write its position in the main log, its own personal stream, its category stream, and its event type stream on commit every time.
Yeah.
So they're always available and they're always readable.
So I see a parallel between Git and event stores in that usually, the number of file handles that you get as you serialize each event and write it to disk is kind of like where things may break at scale. And so most event stores get chunk files, 256 or half a gig or whatever, and you pre-allocate them, and then you just have a something that writes the serialized events into that file at at different levels. So that's a pretty easy mechanism. It's additive only, so you know when you're running out of room and you start using the next file.
Yep.
Git has a similar mechanism for tracking small changes to a large file. Like if you have 100 commits to one large file, and you're changing maybe one or two lines at a time, well, it'll be really silly to have the default snapshot of that file stored
Copies of
100
them, yeah.
times. So there's these
Yeah,
pack files, right? So Git has this idea that there's pack files. So there's a few similarities there of how you get over some of the implications of storing too much or having too many file handles to deal with, that both of these problems kind of explore. But how would you abstract, for example, as you're getting more fine-grained details for the indexing? We started to look at these aggregate-less way of doing transactions where you rely on these indexes. And let's say I have an index that kind of cares about some of the contents of an event. Is there a case, at least theoretically, where you want to abstract an actual field to be a file itself so that you could compose your indexes down to that level using a file abstraction? So in other words, instead of having a user registered event as JSON, you would have
yep.
a user registered with an ID as a directory, and in there you would have property, username, and that would be a file with the contents of the username, and etc. So basically splitting up a serialized JSON object down to a directory structure, you then be able to at least theoretically construct indexing. Obviously the file handle count goes through the roof, but I think as an intellectual exercise to kind of
It
get...
doesn't actually go through the group if you do it correctly. It's one of the things that I think, a lot of people never played with the high level structure and I'm gonna say it bad, the domain driven design.
Mhm.
Right? And if you think about that user ID as a shared core,
Mhm.
right? One of the things I see people not realizing is because like I always run with circuit keys,
Mhm.
right? And I use matching keys on different streams
Right.
with different names to indicate the same, right?
And just for
So
people that
people,
don't understand what a surrogate key is, most people are familiar with primary key, foreign key. A surrogate key is an extra set of information, such as a phone number or something. Is that correct?
I know it's rather using a natural key.
Mhm.
Like I'm gonna say, everybody has a unique name. It's putting
Or
a
an
GUID,
email. Yeah.
right? Yeah, so you can't use an email. You use a key that doesn't collide,
Right, like a
right? So
GUID or
it's like,
UUID.
right, and you want to use one of the good UUIDs that's gonna support ordering, not get you in trouble,
Hmm.
be natively supported in your
So
database.
what are some of those? There's like some Snowflake ID. There was like GUID Comb
Yep.
back in the day, like 15 years ago, where you
All
removed
that.
some of the GUID and lumped in
Yep.
a serialized date and timestamp into that.
I
So you.
think it's called a C. I know SQL Server has it, and I know that's an implementation
Mhm.
of the general one. All of the main relational databases
I'm
have
just thinking
both.
on the command line. If I want to use that kind of an ID and get one
Yep.
going in Node or get one just in Bash, I mean, my go-to is to try to see if I can get a UUID. Then I can replace the first 6 or 7 or 8 characters
Yes.
with like the
So
Linux timestamp or something, right?
all you have to do is grab the sequential GUID. It's available in NuGet. There's a number of implementations of
Hmm.
sequential GUID, and those support
Yeah,
all the ordering that you want.
just have to make sure that
Um,
they're kind of based on a standard, so you don't
yeah,
get collisions as you start to. I mean, one of the things about
get
event
really
sourcing
large.
is creating the ID at the client, not on the server, right? So
Right.
especially when you're
And
doing,
these are really
yeah,
great for that, right?
yeah,
So what it means is you can have a stream that is just a user name, an email, and an ID, and nothing else.
yeah,
So it's not your user events. Nothing goes in the stream but the reservation of the ID and like the email or whatever else you need.
yeah,
And then and that would be like my user ID or user reservation with an ID. And then my stream for the user would be all the user stuff,
hmm,
but it would have already done the reservation. The reason to do that is you can then take that stream and put in a separate file,
right,
right? And you can do what I would call a hard partition. You
yeah,
got soft partitions, which is, hey, I've got one log,
yeah,
and all these streams are soft partitioned inside the log.
yeah,
But then you can say, no, this is a hard partition. These are in a whole separate log, whole separate series of files,
yeah,
and that's for scale and optimization.
yeah. I mean, a
And it,
simple example for people to understand is if you're serializing every event, and then you have a trailing subscriber that reads the events as they come in.
yep,
You could uh, filter, for example, on an ID, what you would
yep,
use traditionally as an aggregate ID. And if you do find a new one, you create, a directory for that by that name, and then start to put soft links inside that directory just to those events. So you're not really taking up extra space, but now
yep,
you've made an optimization where if you have some projection that's needed for changing state of a particular entity or aggregate or whatever you want to call it, you immediately on disk have all of those right there. There is no filtering that you have to do. There is no extra code that you need to run to do that. And so, that's the start of, I think, where people could try to explore what you're talking about, right? With those kinds of schemes. I mean, you could just copy the files too, but I think a soft link or even a hard link,
soft link.
would be good.
But the thing is, realize that because you're using event sourcing,
Hmm.
like when I say a different set of files, I'm assuming it's a whole separate event,
Yeah,
right? That you can actually have. You can make your application not know it's talking to multiple physical storage mediums.
exactly. Yeah.
And you have an optimized one that is just reading from this location. The other thing that I think people don't realize is the power once you start doing that of pre-reserving.
Yeah.
Like I need user IDs to be unique. Well, why not reserve 10 more?
Yeah. Yeah.
Right? And you just hand them out. So you're not trying to grab them, you just take one of the reserve.
Yeah.
And then this
Yeah.
whole thing is all relaxed.
Yeah.
And I'm not struggling on it. And so
Yeah.
maybe I have a couple of gaps and I fill them all later.
I think
But do
that's
you really
often
know?
overlooked. There's all of this like just-in-time activations for scale, and I think these
Yeah,
pre-allocation, not of just servers that are going to take traffic, but also pre-allocation of entities that are
yeah,
spun up and ready to go for whatever you
yeah,
need. So I think that's always pushed to the infrastructure teams
yeah,
and people that are just looking at performance, and rarely do they bubble up to the business concerns. And a lot of times they are. I mean, we use the example
yeah,
of ticket sales and auctions just as they're ending for these types of
yeah,
problems where you finally are kind of forced to do what you're saying. But I think you know, having that approach in your tool belt actually saves you from a lot of other things that maybe don't expose problems when you're reaching scale issues, but they do give you problems with logically thinking about something like, oh, I don't
Yeah.
have this yet. Well, why don't you? Maybe you can pre-make one, like you said.
Yep.
Yeah.
Yeah. And so, and because all you care about is the ID, right?
Yeah.
Once I have a user ID, suppose I'm like creating something large that's going to go in a couple different places, right?
Mm-hmm.
As soon as I have that guaranteed ID and I can reserve, acknowledge the reservation, I can then hand it out to 4 different systems, and they all create an object with that ID key.
Yeah.
And I just know, oh well, the user
Yeah.
information is here, the user audit log is here, the user password stuff is here, and they all just share the same ID.
Yeah.
And my app just knows, oh, I grab these 4 objects with this ID, and I see what I need to see from my user.
This is a fun exercise to do, and I can't wait on my stream to kind of finish the current application that I have, because I really want to take this, like, the everyday person, how do they even start this, right? I want to kind of forget that I've done event sourcing for a while and just say, okay, let's just look at it from like the immediate needs, and kind of think about how someone would solve this by pen and paper before computing, and how does this translate to having these indexes built up as you store facts, and just organically grow the idea. But I think it's really neat when you start to say that, I have my core information. We're capturing all information as it's coming to the system, but now look at all the awesome helpers that are right there on the side, providing you with such easy select star equivalent of getting the
Oh yeah.
information you need to do what you need.
And the thing is once it sort of trips in your mind that you can trust your data,
Yeah.
right? You can trust the sequence, and you don't have to worry about it,
Yeah.
right? Because you've got the locks and the different pieces,
Yeah, you're right.
right?
Because like with traditional systems, you're like, did that table change while I was doing this? Like,
Right.
is that record still the? I don't think people realize just how many issues
Yeah.
mutable data gives you. I mean, we have a lot
And
of
it,
tools written for
and it just
dealing with it.
builds these thoughts in the back of
Yeah.
your head like, oh, I need a transactional lock. I need to do this. I need that. I'm like, well, if I have a stream for this user's login activity, right? And it has that ID for sure. So it's a login activity user ID, and nothing else gets written to it.
Yeah.
Why do I need to worry or transactionally lock something else we're doing with the user,
Yeah.
right? I just append all the activity and watch it,
Yeah.
right?
I mean, you start to get this really amazing feeling as you start to build things on immutable data stores, that you have so much confidence in that map reduce. Like whenever I do events.reduce in JavaScript code, it's like, this is so organized and so easy. Okay, what do I care about? I just slap them into that switch statement, right? Okay, what's my default? How is my little world that I'm going to project going to start off? Right? What little properties do I have with nulls right now, or empty arrays, or whatever? And then I go, okay, let's see an example of some history that will go through this. And even without tests, I'm able to say, okay, well, when this happens, I need to add this little lookup here and update this. I made my own tiny little manageable world to deal with just a part of world history that I care about. It's an incredible feeling, to be able to deconstruct all of these different logic puzzles that we face with business software, to just say, you know what, I see this one step at a time. I see this as isolated from everything else. And now, exploring these other things. Okay, well, when you do have to have a sort of a lock or reservation, how does that play out with indexes, right? Oh, and I have multiple indexes. That's really, really good. And the more indexes I have, and the slimmer they are because they only look at certain things, the more control I have with which ones lock each other. And just like this graph that you're talking about earlier on, it's easy now to walk those dependencies because of this immutable store that continues to grow. These race conditions are so easy to unravel should you get one. Like, it's literally, do you have circular references in Git? No. Why? Because it follows this additive only model. And you can use that exact same approach to all your business stuff. And so it's such a, after years of struggling with the traditional stuff, it's so nice to, wake up and every day know that you can work in a very measured way, where your velocity is really known. You don't get these curveballs from left field because of the high level of coupling or mutable storage. Just the list goes on and on of all these things that just don't exist anymore, right? That I usually see event sourcing as this one-way street, the red pill in the matrix. Right? You just, once you see that ease of use and clarity and transparency of everything, it's really difficult to give that up after. And so, yeah, just a matter of time before more people continue to work this way. But it's fun to explore the possibilities, and like things that people don't ever play with, they can play with now. Like, hey, Joe, why don't you write your own database and an index? Like, what? I have to unravel how Postgres works, and like, forget it, man. I don't have like 5 years to do that. It's like, no, we can do it in a weekend, right? It's awesome.
Yeah. I think we had a junior guy, right? So we started with a non-disk event store that we're still on our backlog to, we had to replace that with a real one.
Yeah.
Right? It'll be real. And it's 2 years now.
Yeah.
And it's still running just fine.
Yeah.
When we move to the cloud, we're gonna enhance it. And we've actually built better one. We just haven't swapped it all over yet.
Well, you don't need all the features of a full-fledged enterprise-ready event store. And there's one that I wrote in 2009 that still runs today somewhere. It might not, but the last time I checked, it was, and it was really, blob, these chunk files that were, I think I chose 256 megabytes or whatever, but it was one printed page of C# code. I kid you not, and that continues to work today, because the only library that it uses is a system.io, right? So like, when has that changed? When has that API changed? Never, right? So there's been like no maintenance issues. It just keeps running.
Yeah, we use the protobufs to serialize everything to disk.
Yeah.
So we didn't have to worry about the serialization. It's just like, bang, it all works, right?
Oh, it looks like Yordis is on our stream here on Twitch. He's saying that I need both of you to build a prod event store from scratch, Kata. That'd be fun. I mean, I think I'm already planning on doing that, but it'd be kind of cool to get together for those kinds of exercises, because I mean, you could definitely see the logic is very similar to how Git works, where you have to write something on disk. Once that's done, then you can do the reference. Like, you have this orderly way of putting in the references to different things. So if you're making a new index, you can only do that after the event's been written and it's there, right? You have the fsync problem and all these things we can get into, but it's really cool to just show that, right?
Disks lie to you. They lie like lying liars.
Yeah. The cheaper the disk drive, the worse of a liar it is, because it probably got that price for some made up benchmark.
Not at all. It's the more expensive the disk.
Oh, really? They give you some crazy number that it's actually not written to disk, but it's the buffer that's been written to still.
Yeah, and there's like 4 layers. Like, there's the is it on the rust or whatever you're using, right? Is it in the disk, the physical disk memory cache? Is it in the RAID cache? Is it in the operating system cache? The file system, so file system cache or operating system cache. So there's like 4 layers of caching that makes everything look smooth.
Well, people can exercise that immediately. Just burn a USB disk of an ISO of some Linux distribution, and notice that you get control right back in your command line. Then run fdisk and see when you get control back, because that's actually what's happening. Or fsync. Sorry, it's fsync, not fdisk. Fsync. Yeah. Or sync. I think it's just sync on Linux. But anyway, needless to say, if
Event Store is open source, so you can go look at where that's done, and everything they're doing to do for Windows and for Linux,
Right.
right?
Yeah.
And actually, Sean at Event Store, who's an amazing engineer, actually went and found some defects in the core, the Linux file handlers
Yeah.
for some of the advanced Disco.
Yeah,
So
I
yeah,
have no doubt. I think there's been well, the Linux kernel is so large, and then you have these vendors contributing stuff, and some
yeah,
of it is sketchy. I don't think Torvalds looks at everything, right? And he's got his specific um, maintainers of different portions of it. So, but even then, it's getting to be quite a large code base. So,
yeah.
yeah. But anyway, these are just like fun things to do, and
Oh,
I think not enough people were playing around with this approach. I mean, they always say, "Well, I got to go back to work, so I'm just gonna keep using my SQL Server. I'm gonna just have my user table or my orders table or whatever. They're gonna keep writing update statements, whatever." But there's this treasure right under everyone's nose of just how easy it is to work off of an ever-growing list of information. That reduce function that you can get pretty much in every language these days. And if it's not, you just okay, fine, just iterate over that stuff and have some variables that'll build up your world for you. So it's doable in any language. Do it in Bash. Um, Probably wouldn't. I mean, there's an interesting thing. So people say, so where would you stop automating with Bash, Chris? What's your litmus test? Like, okay, this shouldn't be a script anymore.
I generally don't bother with scripts. I do very little with
Really?
scripts.
Oh, I do a
Yeah,
lot. Okay, so yours is never. Okay, because I
yeah.
think
I mean,
some of the other streamers they say like um who was it? Oh, the Primogen or whatever. He said, okay, the minute that I stop using a Bash script is the minute that I have to create some sort of a lookup where I have a map of something, I have a collection of something where I start to use arrays. And it's like, okay, you can see it's not the best, but if you take on an immutable store way of doing things, it's not that bad. And if you have a propensity to think in this Unix, everything's a file way of thinking, or Linux at least, everything's a file, you're like, you know what? I don't really care about an array. I'm going to have this delimited set of records on disk, and my sorts and all that will still work. I will have a very easy lookup. So, yeah, it's interesting. The reason I'm bringing this up is that if you are someone that doesn't, program professionally for business, facing problems, but want to get into that, there's a whole bunch of skills that you're not throwing away if you're going to this world. Like you can still make a bash script to make a business facing application. Sure, maybe it's the CLI, like the terminal, that's their interface, but the same patterns apply. There's no difference. And because you have this immutable store, parsing files is very natural. You're as an infrastructure person, you're already used to parsing stuff with grep and log files and digging stuff out of really crappy log files. So imagine if you got the best log file, the one that is the
I'll
state.
tell you
Yeah,
that event sourcing approaches for infrastructure is the best. Right? It simplifies everything
yeah.
compared to anything I've seen written in traditional database. Just the implementing. It's just simple. It's straightforward. You know, kick off this resource create, check on it, come back in, did it happen, move on. The entire workflow is really, really straightforward.
You know what we really
Right?
need in event modeling is a set of templates for how to write the different stress tests for event stores. For example, here's a thing that's competing for ticket sales for front row of a concert in the last as soon as it's launched. Here's the last minute of an auction with maybe one that's got limited inventory or for a single item. I think there's some real world examples that we could have modeled in event modeling and then allow people to implement their own solutions using event sourcing, either from scratch or pulling stuff off the shelf show where Kafka falls apart because of lack of global ordering and these large topics and things like that. You could actually take those um, templates of real world problems and show implementations for each one. Here's how you do it. Here's how you do it. Here's how you do it over and over again. And not only that, but also these could be used as katas in a way for people to kind of implement them and kind of get used to that way of thinking. It's like, oh, I'm really comfortable with like a reduce function for anything I want to show on the screen. That's super simple. And I see how I actually did the exact same work in the traditional way, but it was spread out over all of these different places. I actually did the same amount of thinking and the same amount of work. It just was organized differently. A lot of people don't realize that. They think, oh, event sourcing is more complex. Like, no, the work's in a different place. In fact, then your store is so much better, but you're actually doing the same amount of work. You're just not used to it.
Which I to bring into my classes. Um, actually, it's in my advanced class now. Is we do a diner app, and I write everything as separate modules. Like, as I say, okay, everyone's got their little menu thing at their table, right?
Yeah.
And we just write one menu thing, and we write one kitchen station that receives an order. We say it's a printer, right?
Yeah.
And you just set it up, and I go, okay, now, now this afternoon, and I set them up, and that's going to take a whole afternoon. We're going to take this single-threaded app we wrote, and we're going to scale it out to 50 seats, 3 kitchens, right?
Yeah.
2 managers, right? And okay, I just go start. And there it's distributed.
Yeah.
Like I just started everything this whole day. Like, what are you talking about? Like, here, put everything through. It's all locking. It's all there. It's fully distributed with no effort.
Yeah.
And that's one of the katas of you build everything as if it's single threaded.
Yeah. Yeah,
But it's
exactly.
all
That is,
designed
it's so
to
simple
drop
then, right?
into
Yeah.
this distributed matrix. And it just works.
Yeah. So I think with a traditional approach of like, hey, do whatever you want, and it could be this like, you know, really heterogeneous slapping together of logic. When you adopt this way of working with an immutable store, the fact it's additive only, all this kind of stuff, and everything's map reduce, you get to say that this thing scales, but I'm always thinking in a single thread. So all your mutex stuff, all your semaphores, and all sorts of stuff, compare and swap, things that you think you might need for doing this is just gone. You take care of it in one place once and it's done. It's either off the shelf or you just do it yourself. And man, if you get it wrong, you know immediately because everything fails, right? So
I mean, it's a super simple pattern of I'm going to read from storage and I know what my position is, right?
yeah,
I read 200 events. When I go to save, I just check that the stream is still at position 200.
yeah,
That means that nobody else short circuited, nobody came in, and and if I do wind up getting bombarded with, you do get some edge conditions where highly congested streams might need a pessimistic lock. But in truth, that's actually just a sign that you've probably written something for me,
yeah,
right?
yeah. I like
Um,
how the separation of your infrastructure scaling and everything else is separated from the business logic. So
yep.
we have unit tests for our infrastructure, but I mean, the minute it doesn't work, like everything breaks. So it's almost like you don't need the unit tests because that code never changes a lot anyway, but it's used by everything all the time. So it's like at this point, what is the like? How do you need a unit test? You
What
don't,
are you testing? What's the point here,
right?
right?
Like it's just it can run, it'll pass, but if it fails, all of our clients already have systems that don't work. So before we even notice our unit tests failing, our phone's probably ringing. So
I mean,
that's really neat.
I can see some benefits for them in how you deal with if you're doing like red green deployments and you want to make sure that if it's gonna fail, it fails in your pre-production environments,
Yeah,
right? And so as you roll it out. But you certainly shouldn't have a whole battery. It should just be a couple of health checks.
yeah,
Can I get something? Now, one of the things I've also done really successfully is I've had systems where I've created test messages um, that run across the system silently in production.
Like a dummy
Right?
user? You
Kind
could
of
have
like
a
a
dummy
dummy user,
user to do
but
that.
it's just like um it's a
Like a
test
no-op?
message where you yeah, it's like a no-op. It's a no-op message that goes and
Hmm.
runs a routing loop, and it participates in all of the metrics.
Right.
But it's just there to know, am I connected? What's my latency?
Yeah, yeah. You can
Right?
read the metadata off of the
I read the
resultant.
metadata.
Yeah,
So
yeah,
I just go in like, is everybody up? Is everybody running? Is somebody slow?
yeah,
Is someone on stale? Right? And I
yeah.
know right away. And I'm doing it. What that's really helpful for is systems that have very low traffic volumes.
Right.
Or very on so I can run heartbeats through the system every 5 minutes.
Mm-hmm.
And I know my heartbeat is good. Right? So in the morning at 9 a.m.,
Mm-hmm.
when everybody shows up and uses it, we know we're still good.
Yeah.
And so when you're dealing with a distributed system where, maybe a Russian boot dragged an anchor across a cable
Yeah.
overnight, oh wait, sorry, that wasn't Russian. My
Yeah, leave politics out of our live stream.
bad.
I'm not Russian, so I don't care.
But I know people will care.
Yeah, I know.
I'm just talking about there are things that happen in distributed networks, right? That's all I'm really saying. Is
Yeah.
distributed networks go down, right? And so
Yes.
knowing that your network is down before
And it could be a
that
number of
live
reasons,
call
right? Like
comes through.
people don't even
Yeah,
realize that like routers and switches can get overloaded, and it's like
yeah.
I everything I wrote is perfect, but then it's just the fact that these are separate machines, separate processes, separate
Some
threads.
guy with a backhoe
Yeah,
rocked up
yeah,
to dig a trench at 7 in the morning,
yeah,
and you have an 8 a.m. outage,
yeah,
right?
yeah,
That's
yeah,
actually the most common one,
yeah.
right? With distributed systems,
Yeah,
you
I
know.
mean, even I had a presentation at for the project managers group here in Vancouver on Tuesday, and we had some interesting discussions about that because, how do you talk about units of work? And what we're talking about, the technical level, fully applies to at the business level. What is a unit of work? And I gave him that idea, like you can test how well you understand your system is what happens when you pull the plug, right? Do you have to write your software for a smooth, graceful shutdown, or do you write it so that you can pull the plug at any point in time and it'll just run the minute you plug it back in, right? I always choose the latter. I know I'm not gonna, what if someone pulls the plug during your graceful shutdown? You're in a worse situation, even, right?
That's when you're going to need it. And the other thing is, I've heard people really argue about why you want to do the extra work. But I found when you write it that way, it simplifies all sorts of problems.
Yeah,
Like your health checks are easier, your uptime is easier,
yeah.
right? Because
A lot of
all
this,
because
I can see why Martin Fowler used Git as an example for event sourcing, but he should have preempted it by saying that Git is a snapshot, not an event system, right? It repeats information. But in terms of the referential integrity as you build things, and this idea that Git's really good about, it stands the ultimate test of time for what happens when you pull the plug, right? It is built to be distributed by default, and like there is really very few things that'll corrupt your Git repo. You can pull the plug very readily, shut down the process, pull the plug out of your computer. That Git repo is gonna be pretty much okay, not 5 9% of the time. You're not gonna have any issues. So why are we building applications in a different way where we don't have that same guarantee? You have to kind of think about it. Okay, what is this simple thing that Linus Torvalds wrote in the span of a week or two that we're having trouble with every day for decades?
because that's how you think about it. Now, I actually think that Martin Fowler got the definition of event sourcing right. Now, to give him some credit, he was fairly clear in the article. The people didn't
Well,
read it.
we're talking about
That
two
he
different things.
was
Let's clarify. There's a recent one where he compared it to Git, and there's the original
ah,
2005 article
okay.
in December 2005. So which
Right,
one are you
well,
talking about?
Well, I'm going to start with the original one.
Okay,
Because the
I
original one was
figured.
just a collection of event-driven ideas.
Yeah.
But he called it event sourcing, but when he lumps in change data capture,
Yes.
he lumps in eventual consistency. None of those are event sourcing. I mean, to
Yeah.
me, event sourcing says that your current application state is built off of an immutable stream of ordered history.
Yeah. The
That's
only
your
thing
event
that
state
he's
is sourced.
the only specific event sourcing point that I remember that he made in there is the what if scenario. What if your history of events is this? But even then, you could say that that's just event streaming as well.
Yeah. And so by putting everything into the bucket, people got really confused about what event sourcing was. Because I divided it into you've got the log that everybody knows, which is unordered. And then you go to the ledger,
Right.
right? And the ledger is a series of transactions, right? And then above that, you get into things what I call a stream database, which is an ordered log with database semantics that divides the events into indexable and readable streams.
Yeah.
Right? And that's what we're really talking about with event sourcing.
Yeah.
Right? And the other thing that I think is important with event sourcing is that the event schema should match the business.
Yeah, and I mean, I've gone even
Right?
further. I think each of us that have been swimming in event sourcing for so many years, we've kind of focused on what was the problem for us, that it solved the problems it solved for us. And one of those things for me is, yeah, you shouldn't design your events. And someone in the meetup actually brought up a good point. It's just like, well, then the designer that made the UI dictates the event schema because that is the responsible place to capture the event is at the system boundary. The fact that this person hit submit on this form means that you got this event. This is the influx of information, and now everything is, you know, a projection off of that later. So to make it simple for people, it's like use, you know, don't design events. Use events to design systems, and the easiest thing to do.
I completely disagree.
Okay, I know.
I,
That's the way I've been doing it.
you're trolled. Well, I mean, now the one thing I would say is you're using event modeling. Event modeling gives you good events. Right? There's a whole bunch of structures.
Well, I know why you're
event
saying. Let me
modeling.
interrupt you. I know why you have a problem with this. If I am stupid and I notice that one of the submission form items is something that's already in the system, then I've duplicated, and I don't want
Right.
something that is a ledger where I carry forward a balance. So, in terms of design, it's not the event
Well, no,
design.
I mean, no, I see. Like, it's actually I can think of real world cases where I had people they say, "Well, this screen has the customer name on it,
Yep.
right? It's updating this other thing, but I'm going to put the customer name on the events, and I'm going to save those events and I may rerun my screen with the customer name. But the customer identity was handled by a different system.
Yeah. No, I don't do that.
This was right." And so that's why I get worried when people say just use UI.
No. So here's let
Right.
me quantify it. It's any new information on that form, right?
See,
It is.
if
Well, but
it's
wait,
new
I did already
information,
quantify it. I did quantify it because
yeah,
I said it's the border, the system boundary where new information comes in. The influx of new information that's
okay,
responsible for changing state is your event schema.
that's fine. And while that happens at the UI, that's not the UI is the event.
No.
Right?
I
And
mean,
for
you're going to
someone
have
who
a bunch
doesn't
of helper
understand,
information. And in event modeling, we actually highlight the information that's there to help you. Like, hey, you're on this account or whatever. We highlight that in green. The form, the new information you're typing in, highlighted in blue. And the button, the
right,
submit button, is blue. And when it goes to the command, the blue command, guess what it has? It has only the new information from those fields, right? We're crystal clear about that. Yeah.
that's awesome, right?
Yeah.
And that'll steer you true like 99% of the time, right?
Yeah.
Um,
Yeah. I mean, there
so
are
you
exceptions. Like we've had
you
trading
put something
systems, right?
subtle in there, and you made this nice big general statement, but you actually meant something really
No,
Some refined there.
it's yeah, but I mean, in terms
Yeah.
of a simple rule to understand and help, like, oh no, I don't know
Yes.
how to, oh I don't know how to, design my events. It's like, don't worry about it. Here's some
Yeah.
rules for how the event is designed for you by
Right.
looking at what's happening, right? Studying the
Right.
information flow on your event model will tell you explicitly what the hell your event is. Like it'll jump
So
out at you, right?
so
It's not going to be a
there's three
subjective thing.
questions. So
Yeah,
one is where does it come from?
yeah,
If you get that, you have 90% of it. The next one, that's going to be your next 9. So which is going to be where do I make decisions on this information?
yeah,
Right? If this information needs to be handled in a decision maker that's someplace else, that might change my event design.
yeah,
And you'll know that as you look at where your decision maker. And the very last one, which will get you your third 9 of design,
yeah,
is do I need to do something weird for scalability?
yeah,
And that's what we were talking about before.
yeah, yeah.
Like, am
The
I going to do a
ledger.
separate stream
Yeah.
just for the IDs for the registration, right?
Yeah, but we
So it's
also it's
real,
for like for financial stuff for real time trading.
right?
You
Exactly.
skip the eventual consistency if you embed the current balance or whatever in the event itself, so that it's there
Yeah,
without having to go to disk or memory or whatever to
right.
replay extra things. But those are
Yeah. So
incredibly rare
performance, yeah.
areas, and
That's
you
what you
do
get
not
like
do that ever.
3 9s or 4 9s, right?
Yeah, yeah,
So you get 99% of everything over 2 questions. One, where's it from?
yeah,
That'll get you almost everything. The second one is where do I make decisions with it,
exactly.
right?
Yeah,
Right?
yeah,
So where do I need to know this information? Where do I make decisions? Where does it come from? That's the crux of, and
yeah.
just use a sparse model,
Yeah.
and you'll be able to.
We should do another stream where we're just live coding some of like a
Yeah,
dumb event store. Like, hey, what do I
yeah,
want to,
sure,
project? What do I want to store?
yeah,
Maybe work off of an existing event model or just quickly make one for a stupid trivial example, but maybe throw some curveballs at it, the next session. Okay, imagine this is used by 1 million users and we have this high contention thing. What do we need to do for this 5 9s thing to keep
yeah.
going? Is there one of those design things that we're going to run into in what we put in an
Or,
event
or
or
just do a
not?
simple one like, I actually have a really good set of questions I use sometimes in interviews. It's like, okay, you're building an app with your friends to coordinate going to um 2 and 3 friends, you all live in the same dorm room,
Yeah,
right? You coordinate your weekends,
yeah,
right? How do you store it up? And it's basically a glorified bulletin board on the wall because
yeah,
everybody can see it.
yeah,
And then you put it in that computer. Then you say, well, okay, but now you've all gone home.
yeah,
For the summer, you all want it on your cell phones.
yeah,
How do you distribute it?
yeah,
Well, now you want to have, now everybody's got girlfriends and wives,
yeah,
and they want to use it,
yeah,
and they don't want to see all your events, and you don't want to see all their.
yeah.
So now we need to do user separation,
Well,
and you can just grow
yeah.
this out, right?
And then you want different, organizations, so you get into the multi-tenant and
Exactly.
all sorts of things. But
Right.
those are awesome things to explore
Right.
because, well, at least people can see how easy those changes are
Yep.
when you're doing things with immutable storage, just additive only.
Right.
That these pivots are cheap,
Yeah.
relatively speaking, to anything else out there that's been done
Yeah.
before. It's like it's black and white how you move from this situation to this situation, right?
Right.
But yeah, we should definitely do that. So let's plan on next week.
Sure.
It's Friday. I think it's dinner time for you, probably.
I'm gonna wrap up in a few minutes.
Yeah.
Um. Well, yeah. Let's do that that get together app. So just a simple
Okay.
app to coordinate, getting together and doing events, right?
Yeah.
Because I've already got a really good approach. You build it simple, you keep it simple, and you just keep adding features
Yeah.
that drive different ways and expand it out. And
Yeah, but it's
we've
got
got a
multiple
great sim.
users, so you're starting to really
Right,
exercise, individual
exactly.
streams of information in their coordination,
Right.
potentially locking who wins, optimistic, pessimistic
Yep.
concurrencies, all sorts of
Yeah,
fun stuff.
and you just start off with you assume everybody can see the screen and people
Yeah,
can log in. So you start off with single user, single interface,
yeah,
and it's just spread out from there.
yeah,
Right? And what you'll see if you do it right is the base functionality doesn't change.
Yeah.
All you do is just adding features,
I don't think
and
people
you wind up.
realize how crisp these state transitions are, that they, from this very beginning of one person using the same thing, this case statement and this one reduced thing is keeps living on all the way through to the point where you have millions of users and it's multi-tenant, millions of users in each tenant, co-hosted, separately hosted. That logic is the same because that's what the system does. It's yeah, it's such a refreshing way of working that I cannot work any other way. I'm absolutely spoiled. I am unhireable. I am unemployable at this point.
Wait, so let's wrap up. We'll start doing that next week.
Yeah. All right. Awesome. Okay. Well, thanks to everyone that joined. We'll be back next week. We'll just share our screens and get some code in there and some test cases, some things to click through, and we'll share the repo so people can kind of do it on their own. But I think it would be good to have some sort of a set of katas that kind of come out of it. It's like, here's problem A, problem B. These are the kind of the thought patterns you should exercise and continue. So, I think katas are good. It gets you the muscle memory for thinking a certain way and being good at something. So awesome. Well, always good to see you, Chris.